All right, so I'm going to go into Desmos. I think there's a lot of stuff that's somewhat. This is not in your book. I just need you to pay attention. You can write this down in your notes if you want to, but you're not obligated to do so. So let's say y equals 1 divided by 2 x plus 4. All right, and I'm going to turn that off. Okay. Now to graph this, I know that this 4 is the y-intercept. And the y-intercept occurs when x equals 0. So I'm going to plot the point 0, comma 4. That means that this graph, when I graph it, is going to hit this point 0, comma 4. So thumbs up, thumbs down if you guys understand that. Okay, so in the y-intercept form, when we say y equals mx plus b, the m is the number in front of the x. That's always the slope. This constant, whatever number this is where it crosses the y-axis. So if I were to change this to -5, I'd have to move this to -5. Does that make sense? It's just the way that it works. So when we have this function, whatever this number is, we go to that number on the y-axis and we put a point. Okay, I'm going to switch it back to 4. That's just the way it is. And so there's not a whole lot to understand per se. There is, but if I explain why it's that way, that might confuse some of you. At this point, we can just accept it, right? Most salads are made with lettuce. I don't know why, but I just know that when I eat a salad, it's probably lettuce. Now, are there other types of salads? Sure, right? But so it's the same thing here. When I have y equals mx plus b, right? When I have y equals mx plus b, that last term, the b term, is always where it crosses the y-axis. Always. Now, what does the slope do? Well, the slope is the rise over run. So that means I go up 1 over 2. Now, I have to be careful because I'm counting by 2's. Let me fix that grid real quick. Grid, step 1. Yeah. Put my face over here, I guess. So now I'm counting by 1's. So from here, if I zoom in, from this point, I'm going to go up 1 over 2. So there's a point that's going to go there. What is this point? Well, actually, I'm going to go up 1 over 2. So I'm going to have a point right here. What's that point on the grid? 2, 5. So let's plot that point. I'm going to say 2, 5. Now, how many of you guys feel confident about knowing that that point is at 2, 5? Do you guys understand the x, y stuff? The reason there's a couple like this. That's okay. The reason that it's 2, 5 is when we plot a point on the grid, we start at 0, the origin. To get to where this dot is, the first number is your x value. The second number is your y value. So to get to where that green dot is, I go over 1, 2, and then the second number is the up or down. If it's positive, I go up. If it's negative, I go down. But since I'm going up, it'd be a positive 1, 2, 3, 4, 5. Now, if I repeat that again and I go up 1 over 2, what's this point here? 4, 6. So I'm going to say 4, 6. Now, if I continue this pattern, I could even go in the opposite direction because it's supposed to make a straight line. If I go down 1 over 2, that'd be -2, 3, correct? Yeah. So I'm going to put -2, 3. Now, all those points form a line, don't they? So watch this. When I hit this, well, bam with the bacon sizzle, all those points are on the line. So I can graph a line if I know where it crosses the y-axis, which is 1 point on the line, and the slope will take me to any other point on the line. If I go, watch this, if I go down 1 over 2 in this direction, I'm on the line. Here, if I go up 1 over 2, I'm on the line. If I go up 1 over 2, I'm on the line, because that's the rate of change. That's my rise over run. That's why it's a straight line. So that's the first part. The second part is, if I have another equation like y equals negative 2x, and I don't know, we'll say plus 10. Now we'll do plus 9. Now, same thing. If I close this out, and I want some of you guys, I'm going to point to some kids and I want you to tell me. Okay, I'm going to point to you. What's this number here? 9. Where does this graph cross the y-axis? On 9. Every time. Every time. So it's going to cross right here at 9. So what's this point, you guys? If it's going to cross right here, what is that point technically? 0, comma 9. Now, how do I find the next point on this line? Yeah, so negative 2 is the same as negative 2 over 1. So that means I'm going to go down 1, 2, and over 1. What's this point right here? 1, comma 7. So I'm going to graph that as 1, comma 7. Okay. And if I go down to over 1, look at here. That's a point that's already plotted, right? So from here, I can plot my second line. So what we're doing is we have two equations. I have this equation and I have this equation. And I'm trying to figure out where they both have the same x and y. That's what a system is. Now, where we use this in the real world is maybe I'm making a product and the cost per unit costs a certain dollar amount. And the amount of revenue that I generate is based on a per unit item. And I'm trying to figure out, like, maybe it cost me $100,000 to buy the machines to make caps for a marker, right? Maybe I want to get into the cap business. And I have to spend $150,000 plus it costs me so much material per cap. So I'm going to have this straight line basically, all right? Well, and then I need to figure out how many caps do I need to sell to make a profit, right? And that's going to be a per cap thing. So there's a unit rate of change. And what I'm looking for is where does it break even? This line here could represent the sales, and this could represent the cost, right? I have a really high upfront cost, but per unit it gets less and less and less. And so I would need to sell at least this many caps to break even and more to make a profit. Does that make sense? Anyways, that's what we're looking for. But what we're doing now is algebraically trying to find when these have the same x and y. So when I solve this for y and I plug it into this one for y, or vice versa with the x's, the assumption is I'm looking to where they have the same x and the same y. That's the algebra part. The algebra part is taking an equation and solving for x. So like on problem number 5, we solve for x. Well, we're assuming that x value is the same x value for both equations. So we take this and we plug it into the other equation. And when we plug it into the other equation, on this line, I have y's and numbers. Okay? Does that help at all? The assumption that they have to have the same x and y. And if it doesn't, that's okay. Just say it doesn't, and then we'll try to explain it a different way. No, it doesn't? Okay. So the algebra part is the issue, I think. All right. Have a good day. We'll finish up tomorrow.